Hello everyone. Today we're going to go through a couple of stoichiometry problems that include molarity. We are also going to take a look at the related learning targets so you have an opportunity to check your understanding. These targets are under the High School Physical Science Standard 1.7. Use mathematical representation to support the claim that atoms, and therefore mass, are conserved during a chemical reaction. The related learning targets are: I can identify components of a chemical equation. I can calculate molar mass for a given chemical formula. I can use molar ratios within a chemical equation to calculate change in chemical quantities. I can use molarity, molar concentration, within a chemical equation to calculate changes in chemical quantities. And I can devise a mathematical process to predict the quantity or mass of any species within a chemical equation. Okay, let's look at an example. I can identify components of a chemical equation. Calcium hydroxide, or slacked lime, and sulfuric acid react to produce calcium sulfate and water. Where do you think we should go from here?
First, we need to write the equation.
Calcium hydroxide, calcium 2 plus, hydroxide 1 minus, gives us CaOH2 plus sulfuric acid, hydrogen 1 plus, sulfate ion is 2 minus, so we need H2SO4. That produces calcium sulfate. Calcium is 2 plus, sulfate is 2 minus, CaSO4, plus water, H2O. So, is our equation good?
It's not balanced. We need a 2 in front of the water.
So let's add the 2. Okay, that's a lot better. Okay, now that we have a balanced equation, let's try a problem. How many liters of 1.5 molar calcium hydroxide do you need to have 5.5 moles of calcium hydroxide? What do you think?
We need 5.5 moles of calcium hydroxide. That's the given. The concentration is 1.5 molar. That means 1.5 moles per liter. We could multiply the number of moles we want by the concentration to find the volume we need. Oh, I think we have to flip the concentration to cancel the units. So 1 liter per 1.5 moles?
Okay, so we have 5.5 moles of calcium hydroxide times 1 liter per 1.5 moles. Notice that the moles cancel out, and that gives us 3.67 liters of calcium hydroxide for our answer. Okay, let's do one more. We'll use the same equation. Calculate the mass in grams of calcium sulfate that will be produced from the complete reaction of 5.5 moles of calcium hydroxide. So think about this, and where do we begin?
We're going to need to use the molar mass of calcium sulfate. That's grams per moles. We can find that on the periodic table.
Okay then, for the target, I can calculate the molar mass of a given chemical formula, calcium sulfate. So 1 calcium at 40.08 grams per mole, 1 sulfur at 32.06 grams per mole, and 4 oxygens at 16.00 grams per mole. That gives us a total of 136.14 grams of calcium sulfate per 1 mole of calcium sulfate.
Oh, that's easy. There's 1 calcium sulfate produced for every 1 calcium hydroxide used. So the ratio is 1 mole calcium sulfate to 1 mole calcium hydroxide.
Okay, now let's devise a mathematical process for our reaction. Calculate the mass in grams of calcium sulfate that will be produced from the complete reaction of 5.5 moles of calcium hydroxide. How can we use the information that we've gathered to answer this question?
We can arrange the ratios so that the units cancel and we end up with grams.
Okay, let's put this all together. Calculate the mass in grams of calcium sulfate that will be produced from the complete reaction of 5.5 moles of calcium hydroxide. So we'll start with the hydroxide, multiply that by 1 mole of calcium sulfate per 1 mole of calcium hydroxide, and then we'll multiply by the molar mass, 136.14 grams of calcium sulfate per mole of calcium sulfate. Okay, notice that the way we've set this up, moles of calcium hydroxide cancel, moles of calcium sulfate cancel, and we are left with an answer in grams of calcium sulfate. Our answer is 748.77 grams of calcium sulfate. Let's review our learning targets. I can identify components of a chemical equation. I can calculate molar mass for a given chemical formula. I can use molar ratios within a chemical equation to calculate changes in chemical quantities. I can use molarity, molar concentration, within a chemical equation to calculate changes in chemical quantities. I can devise a mathematical process to predict the quantity or mass of any species within a chemical equation. I hope this has been helpful, and thank you for your time.